All right, so welcome to chapter 7.2, where we're going to talk about types of chemical reactions. In the last chapter, we talked about chemical equations. And scientists use chemical equations to accurately and precisely describe chemical reactions. They tell us what kind of reactants we have, meaning the chemicals we begin with, what products we have, what's left over after that reaction, and how many of those things we have within those molecules. Now, there are 5 main types of these reactions, and the 5 main types are synthesis, decomposition, single replacement, double replacement, and combustion. And each of these has a unique way that the reactants interact to form products, which is why they're all in different categories. The simplest type of chemical reaction is called a synthesis reaction, and this is one where we get 2 or more reactants that come together and bond to form a single product. An example of this is making salt. When we make salt, we start with 2 reactants. We start with sodium and we start with chlorine. And those 2 things will bond together to make one single ionic compound, NaCl. Another example of this is the synthesis of water and carbon dioxide. So we get a water molecule, and that will react and combine with a carbon dioxide molecule to form H2CO3. Now, a synthesis reaction always has this skeleton or this shape. You start with 2 or more separate things, and you always end with one thing where those 2 separate things came together to form the final one product. So 2 or more reactants come together to form one final product. Decomposition reactions are exactly the opposite. This is where we have one reactant and it breaks down into 2 or more products. So an example of this is water. Water, H2O, is one thing that consists of atoms of different elements. And through its decomposition reaction, the oxygen and the hydrogen will actually separate, and we're left with 2 separate elements here, hydrogen and oxygen. This is another example of a decomposition reaction. We have CaCO3, that is our one reactant, and it breaks down into CaO and CO2. So decomposition is the opposite of synthesis, where we have one reactant and that breaks down into 2 or more products. One reactant, 2 or more products. So you can think of decomposition as like something's decomposing. It's falling apart into smaller pieces. Synthesis reaction is like you're synthesizing something. You're taking small pieces and putting them together to make one whole. Now, a single replacement reaction is a little trickier. A single replacement reaction is one in which the element takes the place of another element in a compound. What that means is, if I have a compound and it's reacting with one element, this element will come in and take the place of a similar element in that compound and kick this guy out. So in this example, we have copper and AgNO3. Copper is a metal just like silver is. So copper is going to come in and take the place of silver and kick silver out. That's exactly what happens when we look at our products. Now copper is the thing that is bound to NO3, and Ag is free. So in a single replacement reaction, one thing is replaced. Single replacement. Let's look at another example. Here we have potassium and water. Potassium is a metal. Hydrogen is not a metal, but it has one valence electron, which means it often forms a positive charge when it becomes an ion, so those are similar. So potassium is going to come in and replace hydrogen and kicking it out. So when we look at our products, we're left with KOH and H2. We've kicked the hydrogen out and the potassium took its place. Now, some of that hydrogen was left behind, and that's fine, but this is still considered a replacement reaction because in this reaction, potassium took the place of the positively charged atom in H2O. It took its place. Now, a double replacement reaction is like a single replacement reaction, except Instead of starting with a compound and an element, we start with two compounds. And those compounds will exchange their positive ions, meaning they're going to exchange their metals. So this is an example. We have a compound of PbNO3, 2, and Ki. And what's going to happen is the positive ions from those compounds, Pb and K, are going to flip-flop. They are going to replace each other. That's why it's called a double replacement reaction. So now we get Pb with I, and we get K with NO3. Another example of this is CaCO3 and HCl. So again, the positive ions, Ca and H, are going to flip-flop, replace each other. So we get CaCl and HCO3. Now, it doesn't come out even when you do the math. We don't have just one hydrogen here replacing one calcium. We end up having two hydrogens. But the important thing is that the positive ions are replacing each other in these compounds. So, synthesis reaction is when two or more small things come together to make a whole. Decomposition reaction is where one big thing falls apart into pieces. Single replacement reaction is where one element takes the place of another in a compound and kicks that other one out. And double replacement is where we have two compounds and the positive ions take each other's places. The final type of equation is called a combustion reaction. And a combustion reaction is one in which a substance reacts rapidly with oxygen, producing heat and light. Basically, this is a flame or an explosion. Anything that produces heat and light is within the presence of oxygen is considered a combustion reaction. So an example of that is methane. Methane is a natural gas, and when natural gas is exposed to oxygen and ignited with a spark, those two things are going to combine, and they will end up producing heat and light, as well as letting off carbon dioxide and water. Now, in general, a lot of combustion reactions are going to have these products, carbon dioxide and water. However, not all combustion reactions are going to give off these products. For example, when we take magnesium, just straight up magnesium metal, and we light it in the presence of oxygen, this also produces a lot of heat and light. And this is considered a combustion reaction. But the products of this are just MgO, magnesium oxide. So while it is easy to usually identify combustion reactions by looking at their products, and if their products are CO2 and H2O, it's combustion, that's not the best way to identify them. The best way to identify them is to look at not only what the products are, but also what the reactants are. It has to be happening in the presence of oxygen for this to be a true combustion reaction. So now I'd like you to answer these homework questions, identifying chemical equations as one of these five main types: synthesis, decomposition, single replacement, double replacement, and combustion. And please have this done for tomorrow.